Peter, can you calculate how much stuff flows out of a closed surface?
Flows out of a surface? Like when I open the fridge and cold air escapes?
Surprisingly relevant. We're talking about flux. How much a vector field flows through a surface. And the divergence theorem makes it trivial. Here's a problem. Vector field F equals xyz. Find the outward flux through a sphere of radius a.
Just integrate over the sphere, right? How hard can it be?
Famous last words. The direct approach requires parameterizing the sphere with theta and phi, computing a cross product, dotting with f.
That sounds like a lot of Greek letters having a bad time.
It's tedious, but watch this. The divergence theorem turns a surface integral into a volume integral. The formula, surface integral of f dot ds equals the triple integral of divergence of f over the volume inside.
We're replacing the surface with the inside? That's like judging a burrito by its filling instead of its wrapper.
An apt if disgusting analogy, but why does this work? What is divergence actually measuring? Divergence measures sources and sinks. Positive divergence means stuff is flowing outward at that point. Negative means it's flowing in.
Like a sprinkler shooting water out versus a drain sucking it in?
Exactly. The divergence tells you the local expansion or compression of the flow at each point. Now here's the insight. If you add up all the sources and sinks inside a region, the interior contributions cancel. Only the boundary flux remains.
The tiny flows between neighbors cancel out, and you're left with what actually leaves the whole region?
Precisely. Local divergence sums to total outward flux. That's the divergence theorem. Now let's crush our problem. F equals xyz. Divergence is partial x of x plus partial y of y plus partial z of z. That's 1 plus 1 plus 1. Divergence equals 3. Constant.
Wait, we don't need the sphere parameterization anymore?
Not at all. Triple integral of 3 over the sphere volume. That's 3 times 4/3 pi r cubed. The flux is 4 pi r cubed.
We just multiplied a number by the volume of a sphere? That's it?
That's the power of divergence theorem. When the divergence is simple, especially constant, you skip all the surface parameterization nightmares.
So next time someone asks me to compute flux, I should check the divergence first?
Finally, a neuron fires. Divergence theorem. Boundary information from interior behavior. Follow for more